Hey everyone, this is Subnet 0 and welcome to my channel. So in the previous video, we had learned that real-world companies don't keep every device inside one massive network, right? Instead, they divide it into multiple smaller subnetworks using subnetting. But here's where it gets interesting. In the previous examples, every department received the same number of IP addresses. That was simple though. But real companies don't work that way, right? Like HR, IT, sales, they all may have like different number of devices. Like sales may have 50, HR may have 45, or IT may have like 100. It depends. Completely depends on the staffing that is available. Okay. So, how do network engineers decide how many IP addresses each department should receive? Or even more importantly, how do we calculate the subnet accordingly? Okay, so this video will address that. So let's open our pink circle again. If you've seen the previous videos, you would have guessed it by now. This pink circle represents your own company, which is your own private network. Okay, this entire blob of private networks. How will you arrange it likewise? Yeah. So now let's divide it into three parts. Okay, this organization. This will call HR, this will be IT, and this will be sales. And let's say HR has 50 devices, IT has 100 devices, and sales has 12 devices. Okay. Let's say we have this arrangement. How will we uh, calculate the subnet likewise? Okay. So, a rule of thumb which should be absolutely clear to all of you is that whenever we calculate whenever we calculate the subnet of all the departments. Remember, the one with the largest number of devices comes first. Okay, so we go in descending order. This is the largest, that's why we'll do IT first, then comes HR, and then comes sales. Okay, makes sense? So let's calculate the IT first and see how it works. Just for your information, in this VLSM workflow, the first step is identify each department or subnet that requires its own network. Okay, we've pretty much done this. This circle is your organization, and we have these three departments in it. We've already done this step. Estimate how many devices each department needs to support. Pretty much we've done this as well. This IT is 100, HR is 50, sales is 12. Then choose the smallest suitable CIDR for each department. Now, here comes the real meat of the calculation, okay? So let's do IT first. So, we are taking the usual 192.168.0.0. Now, how will we calculate the slash notation of it? Let's open up our cheat sheet to support 100 devices. Yeah, you see row number 15 and row number 16. Row number 15 is the total amount of IP addresses a network can accommodate. Okay, that's including network and including broadcast. Row 16 is the amount of usable IP addresses in each network block. So, which means we remove the network address and the host address, which is -2, and these are the usable ones. Okay, this one is the total, this one is the total, and this one is the usable. So let's look at the usable ones. Which one accommodates 100? So 0 to 6, 14, 30. Nope, none of this works. 62, it also won't, because we need 100 devices. 62 is too small. So we will go for the next best option. We will go for the best option, that is 126, okay, which is /25. /25 can easily accommodate 100 devices. Yeah. And just for the calculation, without wasting much time, I already created a template. So in this template, the network address would be 192.168.0.0, broadcast would be 192.168.0.127, and everything else in between reusable. So total we have is 128, okay? 128, it can accommodate. Let me do one thing. Let me just minimize this, color code it as green or teal. I like the color teal. I will add it beside this, okay? Reason is this information will be useful later on. Now we have calculated IT. Let's calculate HR comes next. Why? I've explained it to you. Because we are going in, we always go in descending order, okay? So now let's do HR. Now, how would HR be? Okay, in HR we have 50 devices. Okay, so let's open up our cheat sheet. Yeah, we will take /26 because /26 it accommodates 62 devices, which is perfect because we need to accommodate 50 devices. So HR it will be let me just add. It will be 192.168.0.128. Why 128 is because over here the broadcast address ends with 127. Okay, that's why we need to choose the next of it. Okay, and the CIDR will be /26. Okay, the calculation of all the subnets. Sorry, the calculation of the IP addresses would be this. This is the network. This is the broadcast. Everything else is usable. Total is 64. Okay, you can read it for yourself. Let me just color code this green and minimize it and add it on the side. Okay, and now we're gonna do sales. Sales is like 12 devices. Let's open up our cheat sheet. 12. We will take 12 we will take /28. Why? Because /28 can accommodate 14 devices and we need 12. Okay, so it will be /28. Now why we are doing 192 over here? Because the broadcast address over here ends with 191. Make sense? Yeah. And I'm pretty sure by now you would all know how to calculate, how the calculation works. Let me still add it anyway. Okay, this will be the calculation. You can see it for yourself. 192.168.0.192 is the network. Total is 16 IP total 16 IP address this network block consists of. Okay, yeah, I'll add it over here. One thing let me clarify is that the total that you see, it includes the network address and the broadcast address. Why? Because we are going to total it and you'll understand why in the next step. Okay, so this is how we calculate the IP addresses in the subnet, how we design it, how we slice them for each department. Okay, now let's go to our workflow. We have done, okay, pretty much calculate the total addresses space consumed by child subnets. By child subnets, we mean these departments. Okay, the parent would be the entire network, and the child is what we call the subnets inside. Okay, fair, makes sense. Now let's total up the calculation. Now let's total up the number of IP addresses each of these network chunks they accommodate, including network and broadcast. That is 128. That's for IT. Plus 64, that is for HR, plus 16, that is for sales. Total would be 208. Yeah. So if we have this number of 208, so let's open up our cheat sheet. Which one accommodates 208 IP address? That is /24. /24 accommodates 208 because /24 has 256. So the parent of this all of this combined, the IP and the CIDR of the entire company would be, this would be the parent, would be 192.168.0.0 Why /24 is because we have 208 IP addresses that will be in use. So which is why 256 can accommodate 208. Okay, so this would be the parent IP address of the entire company, of the entire network. Make sense? So the key idea behind this is to ensure that we choose the most reasonable option, the best option available without wasting too many IP addresses. For example, in our cheat sheet in the row 16, yeah, which it provides you the slots available, how many slots available to assign it to each device. So let's say if we have 9 devices, then we will not choose /30 because it can only accommodate 2. We will not choose /29 because it can only accommodate 6. However, we will choose /28 because it can accommodate 14. Beyond that, choosing anything extra will just be a waste of IP addresses. For example, we will not choose /27 because although yes, there are 30 slots, we only need 9. So it'll be too wasteful. And we don't need that because since we already have this option of /28. Yeah. So likewise, for example, if we need 17 devices. So for 17 devices, of course, we cannot choose /28 because it can only accommodate 14 devices. We can take for /27 because it can accommodate 30 devices. More than that, like, going for /26 or 25, it will just be wasteful unnecessarily. So this is the core idea behind this, is to choose the smallest number over here, which can accommodate the given number of our requirements. Similarly, let's say if we have 100, okay? So for 100 devices, we cannot take /26 because it can only accommodate 62 devices, 62 slots. Instead, we will go for /125. It can accommodate 126, yeah? And beyond going further left, just increasing the network block is just be too wasteful. So this is the core idea behind this. Also, an interesting part that I want to add, since over here we have 0 to 207, that means we have this many IP addresses pair left: 192.168.0.208 to 255. We have this many IP addresses pair left in case if there is a new department that the management adds. So this gives more scalability and more growth and more options. Yeah, makes sense. So this is how we calculate. The example of is a simple example of variable length subnet masking. So this is how the workflow goes. Okay. So, and also, let's say in cases where you have a small project, okay? This particular workflow can be very useful in organizing and streamlining how each processes goes. Because it's not just about the calculation that is important, it's also about the process of calculation. It should be organized and it should not, it should not take up more of your cognitive bandwidth than needed. Yeah, makes sense? Yeah, this is how the entire infrastructure works. This is an example. This is a very simple example I have provided to you. In the next video, I will be providing you a slightly complex example. The reason why I'm not lumping it into one is I want to prevent learners burnout. Yeah. So this is how subnetting is calculated, and this is like the workflow. It's a very basic example to at least get you how the mechanisms of it behind work. Once you understand the mechanisms behind how it works, you'll be able to scale it and go for more complex architecture. Yeah. Thank you for watching this video, and I'll see you in the next one. Bye.